And, you know, like when we did window size on the graphing calculator, and we did things like, let's say a window goes from 0 to 10. Now we're putting a variable in the middle. So we would not say, well, 0 is less than or equal to 10, which is greater than or equal to, I'm sorry, x is less than or equal to 10, and 10 is more than 0. We would never say that because that's not telling us what x is. That doesn't limit what x is. So we don't ever write them like that. There's not really a use for it. Well, we never write quadruples. At least I never have. And I've taken a lot of algebra and a lot of math.
What do you mean by quadruple?
Well, she was thinking if we had 4 terms.
Oh.
We would never line up 4 terms. When we get to something like that, we might say just put the terms in order from least to greatest or something like that. But, so this is preparing you for this type of work. And you'll see that kind of graphing later on. Okay. So anything else? Anything you want to do? Did you get 16?
Yeah.
So there's a function machine? And a 1 goes in and a 10 comes out. A 2 goes in, a 13 comes out and such.
Yeah.
And you needed to write a rule. So if 1 goes in and 10 comes out, 2 goes in, 13 comes out, 3 goes in, 16, 4 and 19. So you could think of that like this in a t-table. So what's the rule to get from this number to this number?
Wait.
Nobody had the question, so that means every single one of you has an answer, right?
Yeah. Wait, what did you ask?
What is the rule to take this number and get this number?
Oh.
Same rule has to take a 2 and give you a 13.
Every 1 plus equals 3 plus.
Yeah, so the
What is it?
X times 3 plus 7.
Okay. So you take this number, you multiply it by 3,
Oh.
you multiply it by 3, and then you add 7, and then you get this number.
I feel stupid, I wrote 10 minus 3.
that's correct.
So if you took 2 times 3, that's 6. Plus 7, 13. 3 times 3 is 9. Plus 7. Does it work?
Yeah.
Yeah.
Yeah. Check a third one. 4 times 3 is
12.
plus 7. Yeah. So then if you're going to write an equation, it would be like this. 3 times the x plus 7 equals y. If you call that y and you call that x. Number 16 didn't do that. So what you need is something like this, times 3 plus 7. Take the number, multiply by 3 plus 7. It's the only way to get there. Oh, I know, I should get some tape and tape them, right? You don't even need it, because you don't have anyone next to you. That's just like it. There we are. Yeah, that's okay. Okay, then, no other questions? No?
Oh, I have one.
Yeah, Orion.
Number 7.
Number 7. Translate a number times 7 decreased by 2. So take it piece by piece. Is it times 7? Decreased by 2. Okay. So what are the important words up here?
Time to be decrease.
Times, decreased,
Two.
two,
Number.
number. So what is number in math?
And.
Times,
Dot.
multiply, decreased.
Minus.
Oh, and number times how much? Was it 7?
7.
Okay, that's important, isn't it? And then decreased
Minus. Two.
by 2. So n times 7 minus 2. Or 7n minus 2.
Okay, what about 12?
Now we're asking. Much of what we know about math, Egypt.
N plus
What?
N plus N.
Okay, so problem 26 in the papyrus asks the reader to find a quantity such that when it is added to 1/4 of itself. So they're saying a quantity. We got to find a quantity, so something that's it's equal to, such that when I think it has got to be a number that we don't know. So the number is added to 1/4 of itself. So how do we write that? A number added to 1/4 of itself.
N
Yep,
plus 1/4 n.
something like that. Is there another way to write it? Anybody write that differently?
Or you could do it n.25.
Yeah, 0.25, but we don't want to use that. Fractions are your friend, believe you. Believe me. Here, how about this? N over 4.
That's what I got.
I think
Yeah.
how's that work?
That works as well. That's the same thing. And then we would say it comes out to becoming 15. So a number added to 1/4 of itself
Supposed to answer?
adds up to 15. Are we supposed to find it?
Yeah.
I don't know. Does it say so?
I don't think so.
No, it doesn't. But could you?
Yeah.
What would it be?
15.
What would n have to be? A number plus 1/4 of it, and it adds up to 15.
So it's gotta be 7. No, it's gotta be like 14
Six.
and
12?
Oh, yeah, yeah.
What's 1/4 of 12? What's 1/4 of 12? 3. So 12 and 3 is 15, yes?
Yeah.
Okay. How about this? If we took the top one, how many n's is this? 1. So when we add it together, now how many n's is it? 1 1/4. Change this. 4 times 1 plus 1 is 5/4. And how can you solve that to figure out what n is equal to? We did this last year. Yeah, we did.
Then
Yeah, we did.
5/4 minus.
I can't hear you.
N over 1.
No, we don't need to go n over. How do we get rid of 5/4 when it's being multiplied by n?
N over 1.
You divide by 5/4. How do you divide fractions? I heard somebody start to say it. Multiply by, not itself.
Multiply.
When you divide fractions, you change it to multiplication. For example, 1/3 divided by 1/2 is 1/3 multiplied by 2 over 1, the reciprocal. So if I multiply this by 4/5, that's the reciprocal. I have to also multiply this side by 4/5. 5 over 5 is 1, 4 over 4 is 1, so that's just n. Can you simplify this before you multiply? What's 15 over 5? 3. What's 3 times 4? Well, we'll come back to this, don't worry.
Wait, do you have to change the 5? I guess it'd be a 1. So never mind.
3 over, that would be 3 over 1. Divide that by 5, divide that by 5, 3 over 1. Okay, are you done with me? With questions?
I think so.
Okay. Yeah, 50, okay. All right, so this next lesson is 2-3. It's called Evaluating Algebraic Expressions. So evaluating means that we're going to come up with answers to algebraic expressions. So that means we take an algebraic expression and we throw an equal sign on the end and we come up with what it's equal to. So can somebody give me an example of a relatively simple algebraic expression? Yes. N times 3. That's, right there is the expression. If you say equals 9, then it's an equation. So we're going to do just expressions. So right there, n times 3. But now we can't evaluate that unless we know what. What do we need to know to come up with an answer? What n is. So we'll pick a number. 5. Okay, so if they said to you this, evaluate when n equals 5, all you have to do is substitute the 5 in the place of the n, do the calculations, and you're done. Have we done this before?
Yes.
Yeah, we did it last spring during COVID time, home learning. So if you're going to do that, you would just take this n times 3, write the 5 times 3, and then what it's equal to, and you're done. But in your work, I'd like you to start with this, show the substitution, and then the answer. So they won't all be quite so simple. They might be a little bit more complicated than that. So for example, the first example, it says the surface area of a cube with an edge length e is 6e squared. So let's draw a picture of what that looks like. So if it's a cube, that means all sides are the same length. Can you guys draw cubes? No? Start with a square. You can draw a square.
That's a lot of
So start with a square,
Oh, just
then look up here.
because then,
Go to this edge, or this corner, and draw a segment that's sort of like goes about to the midpoint. And then take that segment and draw the exact same thing coming off of this corner. It's got to be the same length, so that when you connect across the top, it's parallel to the top edge of the cube. And then draw another segment down in the bottom right that's the same length as those. So when you connect these, it's straight up and down. And you have yourself a cube, almost. Let's make it so we can see through. Go dot, 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 come all the way down. So sketch in the back and the sides.
You can just run it into square. You can do square in the corner.
Yeah, you can do square, square, and connect them if you want to do that too. That works. But the idea here is we can see that there are 6 sides on the cube. That's what we're trying to see. And the statement at the beginning of this example says that the surface area is equal to 6e squared. So what they're saying is this edge length, the edge along the cube, is equal to the length e. So this is algebraic. And then this length here, going up and down, is also equal to e, because it's a cube. Everything's the same length. And then we go and do the depth. That's also equal to e. So it's like this. But each length, we're going to call it e. We can make it as big as we want. And then the surface area is all 6 sides. So you've got 6 sides of this cube. And on one side, it's e wide and e tall, so that's e times e. So one surface like this, the area is e multiplied by e, which is e squared. And because there are 6 of these sides that are all the same size of my cube, we can just add them all up. But instead of adding e squared plus e squared 6 times, you just say 6 times e squared. So that's where they get this, 6 times e squared. That's equal to the surface area. So now it says to find the surface area if the edge of the cube is 3.5 centimeters. So now e is going to be 3.5 centimeters. So there we go. We've got 6e squared. And all we do is we substitute. 6 multiplied by 3.5 centimeters. And that all needs to be put in parentheses. Squared.
Why do you have to put parentheses around the 3.5 centimeters?
Because it's an entire length, and the length is what's going to get squared, not just the 3.5. But when we draw one side of this, it's going to be 1, 2, 3.5 centimeters. And then we draw another edge, it's 1, 2, 3, and then a half. So here's a square centimeter, 1. Here's another square, which is 1 by 1, 2, 3, 4, 5, 6, 7, 8, 9. And then here's a half, and a half of a square, so there's 10. Here's another pair of halves, that's 11. Here's another pair of halves, that's 12. And this is a half by a half. And a half of a half is a fourth. So all of this is 12.25 square centimeters. So let's go back to this. So this is just to help you see this picture. Yeah?
You said square centimeters, isn't it centimeters squared?
It can be read either way. Square centimeters or centimeters squared. Either way, same. So what is 3.5 multiplied by 3.5? Isn't this 3.5 here?
12.25.
And this is 3.5 here, and I multiplied length times width. 12 point how much?
25.
0.25. And centimeters multiplied by centimeters is centimeters squared. So now what is 6 times 12.25? Because there are 6 sides.
Um, 73.5.
70,
That's 6 times 12.
73.5?
Yeah.
So 73.5 square centimeters. So you took that cube and you counted up how many square centimeters there were total. There'd be 73.5. So this is an example of taking an expression, substituting a value, and coming up with an answer. That would be the surface area. Yes?
This makes no sense. I don't get it.
I need a question from you then.
Like, I don't understand what you're doing with the multiplying on that side.
On this side? Okay, so what I'm doing with this is I'm thinking of this as 6 multiplied by whatever's in here times itself, because this is an exponent of 2. So this is going to be 3.5 centimeters multiplied by 3.5 centimeters. So now I have these 3 numbers to multiply together. This 12.25 is when you take these two and multiply them together, because I left the 6. So 3.5 times 3.5 is 12.25. And then this number here is when we take 6 multiplied by the 12.25. So what's in red is just the units, and black would be the numbers that you're actually multiplying and working together. So the key to these is writing down the original equation, or I'm sorry, expression which is given, the original expression, and then substituting the numbers that they ask you to use. Here. So here's the expression. So this one doesn't have any units. So this is just going to be numbers that get put in place. And they're asking us to evaluate when x is what? 3/4, y is 4/3. And then z has got to be 5/16. Yes.
Why do they have to put those letters in there? Why don't they just put the actual number?
The idea behind this is we're trying to describe patterns, and the patterns are going to be for more than just one example. So in algebra, what we try to do is we try to describe patterns that we see and write generalizations, rather than have to rewrite an equation for every single example of what happens. So we're trying to write patterns that we can follow so we can do many, many calculations at one time, instead of do a complete set of calculations every single time we have numbers. Yes?
Will this be on the year's quiz?
Oh, yeah. I'm not teaching you anything that you're not getting quizzed and tested on, and you're not going to be using in future classes.
Well, I mean, the one like you said this next week,
Yeah, you have one next week. Yeah, this is lesson 3. So the next quiz will be on lessons 1, 2, 3. Okay, so first step, substitute and rewrite the expression. And then evaluate it. You just put the numbers in. And now it turns into a problem with multiplication and order of operations, it's addition. You have to simplify that. So what gets done first?
4.35.
This is multiplication. 4 times 3/4. So this is multiplication here. This is multiplication, that's multiplication. So we have to multiply all 3 of those before we add them.
Wait, what's that Z thing? Is that a Z?
Yeah, that's a Z, because Z's and 2's can look the same.
That was loud.
So 4 times 3/4. How do we multiply this? Yes,
Do 4 over 1 times 3, 4.
okay. So if it's multiplication of fractions, what have I asked you to look for right away?
Simplification?
Yeah, simplification. Can you simplify this before you multiply it? Top and the bottom, can you divide the top and the bottom number by the same thing?
Yeah.
4 divided by 4 is, 4 divided by 4 is, therefore this simplifies into 3. Can you simplify the second one? 3 over 3 is 1 over 1, so that is, okay, can you simplify the last one?
Yeah. 16.
16 divided by 16 is 1, so that's just 5. So this turns into, how much?
13.
13. That's what this work is.
Wait. Oh, wait. That'd just be 12.
That's
Yeah,
12.
Oh, is it 12? Oh, good. You're not sleeping. Okay, so here's what I'd like you to work on between now and when I see you next. Some of it is, yeah. Okay, so numbers 1 through 3, 6, and 8 to 11.
On what page?
I'll tell you in a second before I forget this. 1 through 3, 6, and then 8 to 11. It's not not the whole assignment, but it's enough to get you going on it. That's on page 85. Thank you. So write the original expression, rewrite it with substitution, and then solve. And don't tear pages out of those kinds of notebooks, because then the one that's on the other side falls out later. Yeah.